Hello. Today we are going over the definition of a parabola from the Focus and Directrix. So first off, what is the definition of a parabola? So it is a set of points that are equidistant from a given point and a given line. So a set of points that are equidistant from a given point and a given line. And though that point and that line are going to have a special name, which we'll talk about later on in the notes. So, just some little review. We already know that the parent equation is y equals x squared. Right? We know the vertex, the key point is 0, 0. The direction is up. Right? So it looks like this. Okay, well, what about y equals negative x squared? So the vertex is still the origin 0, 0, but the direction is now down. So, right, we've seen those before. We've seen those in our previous units. We did a lot of that in our first unit. You did some of this last year in Math 2. So in this unit, the equation might look a little different. But it's really not. It's just written a different way. If you can rewrite it and make it look like what you've seen before. So 12y equals x squared. That's kind of different. But what if we divide by 12? So y equals 1 over 12 x squared. So now it looks like what we've seen. It hasn't been shifted. So the vertex is still 0, 0. The direction, it's a positive a value, so it's still going to open up. And what does the a value do? Well, it's going to make it open up. And since it's a fraction, it's going to be wide. So the a value tells you the direction and then how wide or how narrow. Right? Is it very steep or is it really wide, taking its time growing? So if you look at example 2, negative 32y equals x squared. If we just divide by negative 32, you get 1 over 32 x squared. So it hasn't been shifted, so the vertex is still 0, 0. The direction is going to be down, right, because of the negative. So it opens down because of the a value, which is negative 132. And again, since it's a fraction, it's going to be wide. So again, our a value here is negative 1 over 32. Our a value on example 1 is 1 over 12. Right? It's the number in front of the x squared. Right? That is the a value. Right, so there's some relationships among certain features of the parabola. So we have our vertex, right, which is this point here, right? So that's your vertex, right? Vertex, right? We know that. But we have a couple other things. So we have a point inside the parabola, right about here, right? This is what we call the focus, or the focal point. You'll hear both names. So focus or focal point. So that point is always inside the parabola. So that has some special characteristics. So the distance from that point, the focus, to the vertex, we're going to call C. And again, that distance between the focus, which is the red dot, and the vertex, which is the green dot, is a distance of C. Well, the distance from the vertex down to this line at that green dot, or we'll color it blue, this distance is also C. So we have the focus, we have the vertex. This line has a special name. It's called the Directrix. So vertex, that's not new. We have the focus, the focal point, which is inside the parabola. And we have the directrix. So that focus is that given point I was talking about, and the directrix is that given line. Okay. So what's kind of interesting is any point on this curve, right, from the focus to any point, let's say this point here and this point here, this distance here is going to be 2c. So anywhere you want, right, any point you pick, the distance from any point on this line to that red dot, and from the same corresponding point on the other side to the red dot, that distance is 2c. It's going to be twice the distance from the focus to the vertex. And what's really interesting is that the distance from the red dot to this black dot of 2c is the same distance from that black dot down here. So this is also 2c. Now, our graph, it doesn't look like it, but it actually is. So same thing here. This distance down to here would be 2c as well. Again, our graph, it definitely is not what it's supposed to look like, but it is a fact that any point on the curve, the distance from that point to the vertex to the focus is the same distance from that point to that directrix. So any point on the line. So if you picked a point way up here, from that purple dot to the red dot, is the same distance from that purple dot down to that line. Again, our graph, it doesn't look exactly like it's supposed to, but when it's drawn to scale, that is actually what happens. Now, those 2 points that are 2c away, right? So this point, these 2 black points, these 2 black points, which I'm coloring purple, these are called focal chord endpoints. Right? Same thing over here. Focal chord endpoints. And you just want to get used to the terminology because you're going to hear it. So those are focal chord endpoints. The focal chord is the whole length. So that would be this blue line there. That's the focal chord. Right? That's called the focal chord. Right? If we wanted the focal chord width, that's that distance, that would be 4c. Right? 2c plus 2c. So from green dot to green dot, that distance there is what we call the focal chord width. It's 4c. So it's 4 times as big as the distance from the focus to the vertex. You might also hear that called the focal width. So focal chord width or just focal width. Okay, so a lot of terminology, but you'll get used to it. We'll say it over and over and over. The key thing is knowing you have the focus, which is inside, which is the orange dot. The distance from that orange dot to the vertex, which is the green, the dark green dot, which I'm coloring red now, is the same distance from the red dot to the blue dot. And then if you go out from the orange to any point on the curve, it's going to be 2c. And all the way across is 4c. But again, we'll get used to this. So let's look at the y equals 1 over 12 x squared and how that applies to what we just went over. So you have your vertex here, right? It's at 0, 0. Right? Hopefully as you're looking, you see that the c value is very important. Again, it's called the focal length. So c is what we call the focal length. Now, how do we find c from our equation? The y equals 1 over 12 x squared. So C, and this is going to be very important, you're going to want to star this, that focal length. If you notice, everything relates to C on our parabola. There, everything's in terms of C's. You got C, 2C, 4C. So C is the focal length. It's found by doing 1 over 4A. Remember, A is the number in front of the x squared. So that's very important for us. So let's look again, example 1. Let's find the C value. So C equals 1 over 4A. So in our case, A was 1/12. So 4 times 1 over 12. And now we're just going to simplify. So 4 over 12, 1 over 1/3. So remember, it's 1 divided by a fraction. It becomes 1 times 3 over 1. So it's 3. So C equals 3. Again, back to this part. 1 divided by 1/3. It's a fraction divided by a fraction. So we keep the first, which is the 1. Take the reciprocal, which is the 1/3. Now becomes 3, and we change this side to multiplication. Remember, KFC. That's how we did this. So if the vertex is 0, 0, C is 3, right? I'm going to go up 3 units. That's going to be my focus. So this distance here is 3. So that point there would be at 0, 3. And then you would go down 3 units. So this point here would be on the line y equals -3. The directrix is always a line. The focus is a point. The directrix, you go opposite of the focus. So if I go up for the focus, the directrix, I'm going to go down. But it's always the same distance. It's what we call our focal length. That is 3 units. This is our C value, focal length. Okay, so we know the focus is that green dot. So if we go out to here and out to here, this distance is going to be 2C. So 2C, in our case, it's twice as big, would be 6. So if this point's at 0, 3, and you go out 6, now that would be at 6, 3. And if you went left 6, this would be -6, 3. Those are what we call our focal chord endpoints. So then from all the way across this red line there, that would be 4C. So that's 6 and 6, so that would be 12, right? 4 times as big as C. What's 4 times 3? 12. So this is what we call our focal width, or our focal chord width, or our focal chord length, right? You might also see focal chord length. So when it talks about chords, it's talking about, again, just this segment that goes across the parabola. So again, we'll practice it. We'll get better at it. Probably have some questions, but as we go through the next examples, should hopefully make a little bit more sense. So we're going to graph this parabola. So first thing is I'm going to divide by 8. So I get x squared, so 1 over 8 equals y. Now, some of you might be asking, well, why can't we just graph this like we've always graphed it? Okay, well, what we would do is we could use a table, but then you're multiplying by 1/8, so that's going to be fun, right? You're going to get a lot of decimals. Some of you are thinking, well, what about our pattern? You know, our over 1 up A, over 1 up 3A. Okay, well, A is 1/8. So you go over 1 up 1/8, over 1 up 3/8, over 1 up 5/8, over 1 up 7. Like, you're not going to get whole numbers. So it's going to be very challenging. So it has not been shifted at all left or right. So the key point is 0, 0. That's the vertex. Right? That's not going to change no matter what parabola. You want to know the vertex. So now to find the focus and directrix, we need to figure out C. Well, C is 1 over 4A. So in our case, A is 1/8. So 1 over 4 times 1/8 equals 1 over 4 over 8. Right? 4 over 8 reduces to 1/2. So this is going to end up being 1 divided by 1/2 is going to end up being 1 times 2 over 1. So it's 2. So C is 2. Since it's a positive x squared, I know it's going to open up. So I'm going to go up 1, 2. There's my focus. All right, that's my focus. So 0, 2. I'm going to go down 1, 2. It's not a point. That's the directrix. So I'm going to put a dash line here. So this is going to be y equals -2. The focus is a point. The directrix is a line. Definition of a parabola. A set of points that are equidistant from a given point, the focus, and a given line, the directrix. So now, to find the endpoints, right, that's going to be 2C. It's going to be twice the length of C. So if C is 2, twice as big would be 4. So I'm going to go to the focus. I'm going to go right 1, 2, 3, 4. There's 1. I'm going to go left 1, 2, 3, 4. There's the second one. So the endpoints are at 4, 2 and -4, 2. Doesn't matter the order in which you write those two. You can write either one. So now, right, I can graph my parabola. And some of you are wondering, well, it's only 3 points. Yeah, that's what we used to use for our other parabolas. You got to have 3 points. We got 3 points now. Right? We have the vertex and we have the 2 focal chord endpoints. That's all I need, 3 points. So now some of you might be thinking, well, what about 4C? Where does that come into play? Well, 4C, it's 4 times as big as C. C is 2, so it would be 8. Well, that's the distance from the blue dot to the blue dot. That distance of that green chord. And if this is 4 and that's 4, 4 plus 4 is, 8. So these 2 green dots are 8 units apart. That's our focal width. That's our focal chord length. That's our 4C. So C, 2C, and 4C come into play a lot. You have to know the vertex. You have to know C. Because everything is based off of that focal length. The distance from the vertex to the focus. Everything. That's how you find your other 2 points. That's how you find the focus. That's how you find the directrix. So it's a key part is finding C. Okay, example 4. So graph the parabola, x squared equals -6y. Find the focus, directrix, and the endpoints. So first off, divide by -6. So -1 over 6 x squared equals y. So it hasn't been shifted, so the vertex is 0, 0. How do I know it hasn't been shifted? There's nothing added or subtracted to the x squared. Okay, your a value is the 1/6. So to find C, it's 1 over 4a. So 1 over 4 times 1/6. So 1 over 4 over 6, which is 1 over 2/3, which is going to end up being 3 over 2. Or 1.5, however you want to write it. So now some of you are wondering, well, what about the negative? Well, technically, yes, it is negative. But again, it's just a direction. So negative means I'm going to go down. So, and hopefully that makes sense to you because it's a negative x squared. The graph should open down. So yes, technically you could say negative, but that's just a direction. So I'm going to go down 1.5. Right? So the focus would be at -1.5, 0, comma, -1.5. Or 0, comma, -3/2, however you want to write it. And the directrix would be up 1.5, but remember it's a line. So y equals, again, 3/2 or 1.5. Either way is acceptable. Okay, so right now I need 3 points. I have 1 point, the vertex. So I need those endpoints. That comes from 2c. So it's twice the distance from the green dot to the red dot. So if the red dot to the green dot is 1.5, twice that would be 3. So I'm going to go to the red dot, the focus, and I'm going to go right 1, 2, 3, and left 1, 2, 3. And there's my endpoints. So there are my other 2 points to make my sketch. So those would be at 3, negative 1.5, negative 3, negative 1.5, or 3/2, however you want to write it. So if we did this right, 4c is 4 times as big. Right, so that would be 6. So from here is 3. Whoops. Is 3. And from here to here is 3. And 3 plus 3 is 6. But perfect. There we go. So you want to know what C equals. And so notice we were putting this in standard form every time. So I divided by negative 6 to get y by itself. I always got it in the form of y equals, something x squared. So I can figure out what my a value is. And then 1 over 4a, you've got to figure out what c is. Got to know the vertex and c. Those are 2 things you have to figure out. And then you can get the rest from all of that. Wait, so last example. So we have a parabola with a focus of 0, negative 2, and a directrix of 2. Use the formal definition of a parabola to derive the equation in descriptive form. Okay, so the formal definition of a parabola is a set of points that is equidistant from a given point in a given line. So we're going to show that our focus and the directrix are the same distance away from a given point. Well, I don't know that the given point, is the vertex. I don't know what the vertex is right now, or any point on the line, any point on your curve, the distance from the focus to that point to the directrix to that point is the same distance. So I'm just going to pick a random point. I don't know what it is. I'm just going to call it xy. I don't know what it is though. I'm just going to show that the 2 distances are equal. And by doing that, I'm going to derive the equation. So this one's a little tricky. So I know the focus is 0, negative 2. So I'm going to show the distance from that point to the focus. That distance between those 2 points is the same distance between that same point xy and a point on the directrix. Well, the directrix is at 2. I don't know what that other point is. Right? So I'm just going to call it x. So I want to show the distance between some point. So for example here, this point here on the graph above to the focus is the same distance from there to the point on the directrix. I want to show those 2 distances are equal. That's what I'm trying to show. And by doing that, I'm going to end up deriving my equation of my parabola. So here's that random point because I don't know what it is. So show that distance between those 2 points is the same between these 2 points. Again, the directrix is at 2, so that's why I put y is 2. I don't know the x coordinate, so it's just x. So let's find the distance between the left side and the right side. So remember the distance formula is you subtract your x values, square it, add it together, you subtract your y values, square it, and you take the square root. Right? So let's clean this up. This would just end up being y plus 2. And then you do the same thing for the other side. So this distance, so x minus x, square that, y minus 2 squared, add it together, take the square root. That's the distance formula. So again, I'm showing the distance between these 2 points is equal to the distance between these two. And by doing that, I'm going to create an equation. So let's get rid of all this and kind of clean it up. So let's get rid of the square roots by squaring both sides. So this is x minus 0 is just x squared plus y plus 2 squared. X minus x squared, that's just going to be 0. So then you're going to have y minus 2 squared. So that cleaned up a lot. Okay, so again, trying to get an equation, right? I want it in descriptive form, right? So I want it to look something, like y equals ax squared. Okay, so if I want it in that form, there's a lot of y's here, so I need to multiply all that out and try to combine and reduce some stuff, because 1x squared is fine. I already have that here, but I have too many y's. So let's FOIL all of this out. So y plus 2 squared, right? Y plus 2. So this would be y squared plus 2y plus 2y plus 4. So plus 4y plus 4. And then y minus 2 squared. Right? Y minus 2, y minus 2. So y squared minus 2y plus 4. So minus 4y plus 4. So again, if you're wondering how I did all this, right, I quickly FOILed y times y minus 2y plus 4. Y times y is y squared plus 2y, right, plus 2y plus 4. So now, starting to look a little neater, I have y squared and y squared. So if I subtract those y squareds are gone. Okay. So now if I subtract 4 and subtract 4, those would be gone. So I have x squared plus 4y equals minus 4y. So let's subtract 4y over. So I have minus 8y. Okay, that's kind of looking like what we want, right? Kind of looks like y equals ax squared. We're almost there. Well, if we just divide by negative 8, we get y equals negative 1 over 8 x squared. And there we go. There's my equation. So I was able to show the distance between some random point. Again, where did I get the random point? I don't know what it is. I'm just calling it xy because I don't know where it is. I don't know anything about it other than it's on the parabola. So the distance from that point to the focus, they gave me the focus in the question. That distance between those 2 points is the same distance between that same random point on the parabola and the point on the directrix. How did I get the point on the directrix? Well, they said y is 2. So I put 2 there. I don't know what the x coordinate is, so I just put x. And then all I did was find the distance between those 2 points using the distance formula. Doing a lot of algebra, right? I want it in descriptive form, so y equals ax squared. So what I did was, take the square of both sides, get rid of the radicals. A lot of things reduced, and then I realized, okay, I had y's on both sides here where I'm underlining in purple. So I multiplied all that out so I could hopefully reduce. And I was able to reduce, right, the y squareds. I was able to reduce the 4s. So then I get down here to this part with the purple arrow, and I see, okay, now this look a lot neater, right? I just have y on both sides. So subtract the 4y over, and now it's starting to look a lot like what I'm trying to get to. Divide by negative 8, and I get an equation that's y equals negative 1/8 x squared. So perfect. So that is the challenging part. Again, we'll go over this more because this is definitely a challenging example. Again, the main takeaway is you need the vertex. You need to find C, which is 1 over 4a. We have what we call our focus, which is the point inside the parabola. We have the directrix, which is the line that's outside the parabola. Those distances are the same distance to the vertex, right? That's our C value. We have our focal width, which is the distance between the two purple dots here that I'm coloring on the screen. This is what we call our focal width. That's that 4C. We have our focal chord endpoints, right, where I'm pointing the arrows. Those are our focal chord endpoints. We still need 3 points to graph our parabola. All that's the same. That hasn't changed. The vertex, you find the vertex the same way that you found it since you learned about parabolas in Math 2. That never changes. So please make sure you answer the essential question with a 3 to 5 sentence summary at the bottom of the page, and you'll be done with your notes. Have a great day.